Hello everybody, welcome back to another one of my PowerBox series of videos. Today we're going to be looking at the PowerBox Mercury again. We're going to be going through a basic aircraft setup again. However, we're also going to be introducing the iGyro gyro sensor. So for those of you that are not aware, this is a little tiny separate sensor that plugs into the fast track port of your Mercury, Pioneer, Competition or Royal SR2, and this provides basically a gyro function on all your flight surfaces, for instance on your rudder, ailerons and elevators. Okay, now for this particular video I'm just going to be covering off a basic setup. In the next video I'll go to a more complicated setup where we use multiple servos per flight surface. There's a lot of people that get confused when it comes to multiple servos, and for instance, I can show you how to connect, say, 4 or even 5 servos per flight surface. Many people think because the Mercury and, for instance, also the Competition, I think they only support 3 gyro outputs per flight surface, you're limited to only, say, 3 servos, but that's not true. I'll show you how to, say, connect even, I don't know, if you had 5 servos on your ailerons, 5 servos per aileron. I'll show you how to do that, for instance, on the Mercury. It's quite easy, but we'll cover that off in the next video. Anyway, let's move on. So, let's have a look at our function. So I'll show you how we've set up this fancy aircraft. We've got a throttle, but you can sort of ignore that for this video. Our ailerons, we've got 2 servos, so on channel 1 and 2, or servo ports 1 and 2, I've got aileron left on the odd numbered servos, so servo 1 is aileron left, so that's our left aileron, and our right aileron is the even numbered servo, and I've just got the default throws here for this example. Obviously you can manipulate them later to suit your aircraft. Now for the elevator, remember I said we've got a split elevator for this example, so I'm using 2 servos for my left and right elevator halves. And the same thing here at the moment, I've got a plus or minus 100% throw, nothing too crazy. So, you know, as I move my stick there, you can see the channels moving. I haven't set the direction yet, so I'll show you in the next few steps how we do that or when we do that. So at this point in time, we don't have to worry about that. Let's see, what else have we got? I've got our rudder, so just a single channel for our rudder, channel 7. Or servo port number 7, and again just plus or minus 100% travel. If we go further down, since we're going to be using a gyro in this video, I haven't connected the gyro at this point in time, so I don't follow the procedure that's laid out in the instructions 100% because I've got my own preference which seems to work a little bit better, so just keep that in mind. However, I have currently set one of my rotary controls to the as a gyro gain function on channel 10. So if we go to the servo monitor screen, you can see output number 10 or channel 10. I've got gyro gain, and I've limited it to plus or minus about 49, what's that, 50% roughly, if I move the knob around. So the reason I've got plus and minus is for those PowerBox users that are aware, there is throws either side of the neutral point, basically give us heading hold or no heading hold. I mean, you can have heading hold in both. It's just basically a function of the gyro. It gives us 2 setup options. What else we got here? We've got the capacity reset button, which I showed in an earlier video. That's just a hangover from that video. And we've got a sequencer on channel 12, and I'll cover that in another video. And also probably in 2 more videos I'll cover off a model which say uses vectored thrust, just to show you a different configuration with the servos. So I've set those up, but I haven't actually given them a actual control at this point in time. So for this example we're just going to be concentrating on the aileron, elevator and rudder plus the gyro gain channels. If we have a look in the gyro gain, you'll see I've just got 50% plus or minus 50%. So this gives us, you know, plus or minus 50% throw either side of the neutral depending on where I position my rotary control. So that's fairly simple to understand. Okay, let's move on. So that's our normal aircraft, and I've actually got some servos, so I'll move over to the servos in a second so we can see those, as well as the screen from the Mercury. So I've just got that stuck to the side of my core screen. It's just a convenient spot. And if we're going to start setting up an aircraft, we're going to want to use the setup assistant. So let's go into the setup assistant. Now remember, so we're going to be using an iGyro. At the moment, the gyro sensor is not plugged into my Mercury, and we can add the sensor at any point after the initial setup. And I prefer doing it this way because I like to get all my servos working 100% in the correct orientation, the correct throws, before I add the gyro sensor. And typically when you set up an aircraft, you would fly without the gyro sensor switched on, do all your trims, land, make sure your trims and throws are set correctly, then you would activate the sensor. In the manual, it sort of steps you through plugging in the gyro sensor up front and stepping through the whole sequence of events. In other words, set up the servos, the sensor, the gyro sensor that is, etc., etc. However, like I said, I do it slightly differently. I prefer to set up the servos first to make sure the aircraft is set up 100% with the correct servo throws. I would probably then fly the aircraft, and then I would add the sensor afterwards. Anyway, let's have a look at the setup assistant. So let's move over to that servo matching, sequencer. I'll cover those in a later topic. Now we don't have to worry about input mapping, so if you watched my last video, that's going to be done automatically with the setup assistant. So here we are, the setup assistant. Let's have a look. So standard wing type, so we haven't got any delta or anything like that. Same with the tail, I've just got a standard elevator on the tail, except we're going to be running the 2 servos for the tail. No vectored thrust tube or anything like that. So let's hit next. So this is very similar to the last video, so you should be following this fairly easily. Now, remember, the first number is the amount of the functions we're going to have. So we've got 2 ailerons. We've got a separate left and right aileron. So we're going to have a number 2. The first number is number 2. And the second number, the 1, so we've got a 2 by 1. That refers to the number of servos per surface. So as far as the aileron's concerned, for this example, we just got 1 servo per aileron. However, we've got 2 ailerons, so you've got a 2 by 1 configuration. So we can leave that as it is. So moving down to the elevator. Remember in this example, we've got the 2 elevator servos. So we've got a single elevator. However, they're going to be controlled independently. So we've got 2 functions, if you like. We've got a left function and a right function for the elevator, because it's a split elevator for this example. So again, the first number over on the left-hand side has to be a 2. And we've only got 1 servo per surface. So 2 by 1. Now hopefully you remember this from the previous video. It's fairly straightforward when you understand it. And the rudder, we've just got the single function, so just got 1 function for the rudder and just the 1 servo, so that's just 1 by 1. Now moving on to next. So this is where we actually set our servo, or basically our input channel. So this is where the unit automatically does the input mapping. So if I move my aileron stick, you'll notice the dashes will become numbers referring to the 2 channels that we're using. So if you look at my core screen, we've got channel 1 is aileron left and channel 2 is aileron right. So we've got to make sure that matches the screen here. So the screen here shows aileron right with channel, well basically channel 1 or port number 1. And aileron left is 2. So we don't want that, we want the opposite. We want the even numbered servo to be on aileron right. So all we need to do is move the aileron stick again, and you'll notice those numbers toggle around. So again, this is just straight from the previous video, we can toggle these numbers around. So when we have the right configuration, like you can see now, we've got channel 2 on aileron right, and the odd numbered channel, channel 1 on aileron left, which matches the radio. We can then go to next. So here's where we do the same, but for the elevator stick. So when I move the elevator stick, the two elevator channels will move, and this will auto detect those channels. So here we go. So we've got elevator right is 5, elevator left is 6. We want the opposite. We want right to be 6 and elevator left to be 5. So I just move the elevator stick again. And there we go. We've got 6 now on the right elevator, and the left elevator servos basically channel 5, which matches the radio. Okay, let's hit next. And the rudder, it's just a single servo, so if I move my rudder stick, and you'll notice on the course screen we've got channel 7 moving. So that's fairly straightforward. You can probably hear a servo moving in the background. So that's channel 7. And the assistant is now complete. So basically, as per the previous video, this has just set up our servos in regards to mapping the correct channels to the right ports. And I've plugged in some servos into the default ports. You probably noticed, let's go through the setup assistant again. Just scroll down here quickly. You'll notice the ports are on the right hand side. So I've already plugged in some servos to these ports. These are the default ports. So you can see aileron right servo should be plugged into port A on the Mercury, which is the first port. And aileron left should be in port P, so which is the last port. The elevator servos, you've got elevator right should be in port B, and left is in O, which is the second to last port. And the rudder servo is just plugged into port C. Now again, we can remap those ports. You don't have to plug them into those ports, but they're just the default ports. Okay, now what I'll do is I'll move over to a different view so we can view our servos as well, because I want to set up basically the centers of the servo, make sure the servo is roughly centered correctly for this example, and this is where you'd say adjust your throws as well. Okay, so just hang on a sec. Let's change the camera view. So now I've brought the servos into view. It's our little aircraft here. I've got 2 aileron servos. Now hopefully these are in reasonable focus. It's a bit tricky trying to get the screen and the servos, everything in focus. I've only got so much light in here, so I've got a reasonably shallow depth of field. However, we've got a left aileron on channel 1, a right aileron on channel 2. I've got 2 flap servos which we're not using for this particular example, so they'll just stay where they are. I've got an elevator left on channel 5, elevator right on channel 6, and then this last servo, the vertical servo, is our rudder servo, so that's on channel 7. Now, assuming we've mapped everything correctly, if I move my sticks, there's my elevators are moving, however they're moving in the wrong direction. They should be both moving in the same direction together. Our aileron servos are moving, but 1 or 2 of them need reversing. And then our rudder servo, that seems to be moving in the correct direction that I want it to. So right's over on the right hand side, left is left. So the rudder servo looks okay. I could probably add some centering to get it perfectly vertical. Okay. Let's move over to our normal servo screen where we can actually adjust the travels or the centers, etc, etc. So our aileron servos, if I move aileron say to the right, I want my right hand side servo, so servo that's plugged into channel 2 to move in the opposite direction, and same goes for the left aileron servo, so they're both moving in the incorrect direction, so we need to reverse those two. So again, straight into our normal servo screen here, we can just basically long hold or long press on the normal reverse switch. So now if I go right aileron, I've got the right hand side servo moving up, left hand down, mimicking an aileron on our wing, so that they're now moving in the correct direction. And they're reasonably close enough to center, the same center, so we don't have to adjust their center position. Moving on to the elevator servos, so let's get out of the aileron servos. Let's move into the elevator servos. Again, we've got elevator left and right. Let's have a look. So if I go up elevator, I want both servos to move up. However, you'll notice the left-hand servo is moving in the wrong direction. The right-hand servo is moving correctly. And obviously if I go down elevator. So basically the servo on channel 5, which is our left elevator servo, just needs to be reversed. So again, long press, and now they're both moving in the same direction, which is good. However, you'll notice that they're not quite centered 100% for this example. So let's pretend we need to center the left-hand servo to match the right one, because the right one's pretty close. So let's move the center position. Let's see what it needs. You may not see it exactly on camera. That's pretty close there. That'll do for our example. So I've got 15% for the left servo. And our rudder servo. Let's see, rudder servo channel number 7. It was working in the right direction. So if I move my rudder stick to the right, the servo moves to the right. Left, left, assuming that's the way we want it to move. So for this example, I want it to move to the right. And the center's pretty close, but it's out maybe a little bit. So yeah, that'll do. 4%. Close enough. So normally you'd go along and set these up in your aircraft, so you'd have your, you could set your throws, your endpoints basically, and also your centers, and also the direction of the servos. So remember, as far as the Mercury is concerned, we don't have a gyro connected at this stage. We'll add that in a second. However, we've just gone through and made sure that all our servos are working correctly. So we're plugged into those ports on the Mercury that the assistant told us to plug them into. And lo and behold, they're all working correctly as far as all the controls relative to our core radio is concerned. So we're happy with that. So now normally what would happen is you could go for a fly and basically fly around, set your trims. You might find, you might need a bit of, elevator trim or whatever for neutral flight. So you need to do that before you activate the gyros. So we can add the gyro, but before you activate it, basically all your endpoints and your centers must be set correctly. Because when you're in heading hold mode, if you're using attitude assist mode / heading hold mode, so attitude assist is the term that PowerBox use. You've got to make sure that you don't adjust any of your trims, because if you do, that can then set the gyro off in that direction or the opposite direction, depending which way you move the trim. So whenever you say alter your endpoints or the centers, which is basically what your trim does, it adjusts the center point of your servo, you have to go through the gyro setup again, which is not hard to do. It's pretty basic, and we're going to do that right now. So here we go. I'll grab my iGyro sat sensor, and what we're going to do is I'm going to plug this into the fast track port, and you'll see if I go back to the main screen, you might not be able to see the screen very well at the moment. However, the screen has a little indicator on the left hand side. When the gyro is connected and it's working correctly, it'll say gyro OK. And not only that, you'll see it on my core screen as well. So I've got a little status widget, and you'll notice at the moment it just says RX1, RX2 OK, because I've got the 2 receivers connected to it. However, when we add the third sensor, which is the gyro sat sensor, it'll also indicate gyro OK, assuming it's working. Okay, let's turn it all off, and I'm now going to connect the gyro. I won't show this on the video, but I'm going to connect it to the fast track port, and we'll switch it all back on again. And I might just switch back to the screens, or zoom into the screens so you can see the status screens a bit better. Okay, now we've focused or zoomed into the screens. Both screens, we've got the core on the left and the little Mercury OLED screen stuck to the side of my core display. And you'll notice the widget in the core on the left hand side of the screen just here is indicating gyro OK as it scrolls around, checks RX1, RX2. And as you can see there, it's saying gyro OK, and then it will just keep scrolling around to those 3 devices. And also on the OLED screen of the Mercury's display, notice on the left hand side, just underneath the battery voltage indication there, it indicates gyro OK. And this is because I've plugged the iGyro sat sensor into the fast track port. So here's our little sensor. So just before I moved the camera, I plugged it into the fast track port, and the Mercury has detected the iGyro sat sensor correctly. Now, as you notice, I'll move the sensor around. You can't hear any servos moving. I do have servos connected, so you can hear the servos there as I move my stick. However, if I move the sensor, nothing's happening. And there's two reasons for it. Oh, actually one, because I had the gyro gain set to -50, so that if it was enabled, the servos would going crazy now, just moving the sensor. However, the main reason is because we haven't gone through the setup for the gyro, so the system has not activated the gyro. So even though it's connected and it's detected it, it's not actually active at this point in time. Also, one other thing to be aware of is when it is finally active, this will adjust our gain from the transmitter. However, just remember that when we get to 0%, the gyro is disabled. So it's not zero gain, it's actually totally disabled. It doesn't do anything. And you've actually got a little bit of leeway here. So I measured it at around about -5 to +5%. So if you're at 0 plus or minus 5% throw on your servo channel, the sensor is basically disabled. So that's a handy way. If you set that up on a switch, it's an easy way to remember how to disable the gyro in flight. If you set it to 0% gyro gain with a switch, the gyro is basically switched off. So just something to remember. Okay, let's go ahead and set up the gyro sensor now. So there's two things we need to do. One is to basically tell the system which orientation the sensor is mounted on the aircraft. Because we could say mount it with the wire facing forward. We could have it rotated 90 degrees with a wire leaving to the left. You could mount it in this direction. You could even mount it with a wire leaving towards the rear of the aircraft. We could even mount it, in some cases you might need a situation where the gyro has to be upside down. And again, it doesn't care. So when we go through the learning setup, it'll learn the position of the gyro relative to the movement of the aircraft. So it'll know, the system will know how you've mounted it, how you've mounted the sensor. So you're teaching the mounting position. And you can do that from the screen if you've got a core radio, or you can just do it through the OLED screen of the Mercury. And what else? Oh, the other thing is a lot of people think you need to mount the sensor right at the center of gravity of the aircraft or close to it. Well, that's a lot of baloney, because basically that's not true. So these are a rate sensor. So basically you could mount this on the tip of your aircraft, because you've got to think about it. You think about an aircraft that's flying, and then it's got an aileron input and it rolls, so the sensor will roll. So if I mount this sensor on the wing, for instance, not that you will, but say you mount it on the wing, the rate of rotation is still the same whether it's on the wing or in the fuselage. The whole aircraft is rotating at the same rate. So the sensor is picking up the rate of rotation, not the velocity or whatever, it's picking up the rate of rotation. So yeah, that's a real big myth, and I used to hear this back in the early days of helicopter flying, and it's the same deal with helicopters. Typically, we use it on our tail, the gyro on the tail, so it's detecting rotational movement on the tail. These days we've got flybarless helis as well, so we've got 3-axis gyros. However, you've got to remember these detect the rate of rotation and not the speed of rotation. So again, you can mount this up the nose of the aircraft. So for instance, in a turbine, you want to keep it away from the turbine, because you can get very high frequency sounds produced, sort of subsonic sounds, and they could impact the sensor. So the idea is you mount these away from your turbine. You don't really want to mount it near the turbine. So up in the nose of the aircraft, not a problem. Okay, let's reconfigure the screen so we can see a bit of servo action, and hopefully you can still see the screen, and we'll set up the gyro sensor. So now we're having a closer look at the OLED display on the Mercury. I was trying to work out how I was going to show these next few steps. So I think what I'll do is we'll have a look at the OLED screen, and then we'll step back out and we can have a look at the sensor as I move the model aircraft that I've got. And then we'll go back to the OLED screen for the next step, etc, etc. So hopefully that works out okay. Okay, now we're going to set up the iGyro sensor. So we've set up all our servos, the system's happy with our servos. So there's two ways of setting the sensor. First one is you could go to the setup assistant. So you could go back to the setup assistant, and in this particular version of software, basically the setup assistant can be entered whenever you want, and the system remembers the settings. So you'll notice these settings, they haven't changed since last time we used them. And you can step through it, and then once it's done the servos, it'll then go to the gyro itself. So if I just go back out of it, and there's another way you can go to it as well. Just get out of this. You can also just go straight to the iGyro menu as well. So remember, we've now connected the iGyro sat sensor. The manual normally says to connect it first before you set up the servos, but I prefer to set it up or connect it to the system after I've set up the servos. A little bit of differentiation there. Anyway, we can go straight to the iGyro menu. We can go into this menu, and you'll notice we've got parameters that we set up in the gyro, and normally you'd set these up to basically to your preferences. The manual's actually pretty good explaining what these values do. If you scroll down, you'll notice you'll get to a menu where it now talks about the teach mount pos, or teach the mounting position of the gyro sensor. So the first thing we really need to do is basically tell the system how the sensor is orientated. So remember, you can rotate it around, you can have it mounted upside down, doesn't really care, but the system has to know how it's configured. And it does this by moving, we move the aircraft in two different modes, and basically the system can then work out how the sensor is orientated. It's pretty easy. It's not very hard to do, so let's enter this Teach Mount Position menu. Now, you'll notice it says move the tail up and down. So basically we're going to move the tail up and down on the aircraft, and you'll notice the arrow will move up and down as we do it. And then there's an extra step down the bottom of the screen, it says then hold up. So the idea is you move up and down a couple of times, and then you move it up reasonably sharply and hold it up. So if the sensor is mounted in an aircraft, you can just move the tail of the aircraft up and down, and then move the tail up and hold it up. So it's referring to the tail. So myself, I fly a lot of helicopters, so everything's when we set up gyros and everything's referenced to the nose of the aircraft or the nose of the heli. So yeah, for me it's a little bit odd, but for you aircraft people, it's not really an issue. Just remember it's relative to the tail movement. So let's have a look at my model aircraft that we're going to use for this example, and we'll step through this single step where we move the tail up and down, and then move it up and hold it up until the system detects that, yep, that's the tail, and we're holding it up, and that'll basically configure the elevator movement as far as relative to the position of the gyro sensor's mounting location or orientation. Okay, so here we are with my fancy glider, and we've got the iGyro sensor on board, iGyro sat I should say, and the first step, got to teach the tail in the up and down direction. So we're going to move it up and down a couple of times and then hold it up. So move it up and hold it up. So here we go. So move it up and down a few times, hold it up and watch the servos, and you'll notice they've come back down to their normal center position. Now I'm trying to move the aircraft very lightly because I don't want to confuse the gyro, because I want to go back to the OLED screen now and show you the next step. So this is the next step. So once we've done the up and down movement, it'll now ask us to move the tail left and right then hold right. So basically now we're going to teach it the left and right rotation basically of the aircraft. So with the up and down and left and right rotation, the system can automatically work out how the sensor, what orientation the sensor is mounted in the aircraft. Okay, let's try that step next. Okay, so what I found playing around with this is it kept timing out, so I'm going to have to show you the up and down again, and then we'll do the rotation as well, all in one take. So let's do it again. So up and down, tail up and down, hold it up, servos then free. So then we bring it back down a level, and now move the aircraft left and right, and we're going to hold the tail to the right when we're happy with that. So hold it to the right, and you'll notice the servo has centered. And now let's go back to the OLED display and let's see what it tells us, or what it's asking us next. Okay, back looking at the OLED display, and it's now asking us to hold the aileron stick over to the right hand side. So basically those first couple of steps with the aircraft where we're moving the tail, that defines the orientation. So the system is now happy with the orientation. And the next step is the system has to learn the maximum amount of travel that we've set. So this is why you need to make sure your endpoints and that are set before you set up the gyro sensor. So this is where the gyro itself learns our endpoints, and it uses those to know how far to move a servo if it needs to correct during a flight condition. Because basically you don't want the gyro overdriving your servo, or on the opposite side you don't want it to not put enough input in. So by moving the stick over to the far right, for instance, it'll learn the far right position. It will then ask us to move it to the left. It then learns the leftmost travel position. It then does the same for elevator and also rudder. So it learns those flight surfaces endpoints basically. And that's a critical aspect of it. So again, whenever you change those, if you need to change those on your aircraft after you've set up the gyro, you have to run through this gyro setup procedure again, just so it relearns all those points. Okay, so let's follow the display. So it says hold the aileron stick to the right. So I'm just going to move my aileron stick, and I'm holding it over to the far right. And then we have to press the set button. So I just got to press the set button on the power switch. And now hold it to the left, so aileron stick to the left, and press the set button again. So you've still got to keep holding the stick, then push the button, and then you can let the stick go. Pull the elevator stick down. So just be careful here. It's not down elevator, it's actually up elevator. So notice where it says pull the elevator. So we're going to pull the stick towards us. So that's usually up elevator. So I'm pulling the stick, so giving it full up elevator now, and I'll push the switch on the power switch. And now we're going to push the elevator stick. So some people get a little bit confused with the wording here, where it says push the stick or the elevator stick up. They're thinking up elevator, I've got to pull the stick, they get a bit confused. So definitely it's pushing the elevator stick, so it's giving down elevator input. So I'm holding the stick far forward on my radio, and I'll push the button on my power switch, and now we're doing the rudder. So same thing, full right stick on the rudder, push the button, full left stick, push the button, and now the gyro assistant is fully completed. Okay, now let's see how it all works. So if I move back to the servos, so we can view the servos in the aircraft, we'll see if the servos sort of work in their intended direction or not. So actually, before we move on to checking our servos and the gyro operation, I forgot to mention one thing. We need to set up one more thing, and that's the actual gyro gain channel. We have to tell the system what channel we're going to be using for the gyro gain. Now, the system itself can support multiple gyro gains. So typically you might use one separate gain, say on your aileron, a separate gain for your elevator and a separate gain for your rudder. The system can handle that, not a problem. But generally, initially on your first couple of flights, you'll probably just use the one channel to get the gain roughly in the ballpark, and then you can fine tune it later as required. So if I go back to the function menu, so just to refresh everyone's memory, remember we're using channel 10 for our gyro gain. So we've got a rotary control on channel 10. Now, if you follow the book and go through the normal setup assistant, all the way with the gyro connected from step 1, it'll ask you for the gyro gain channel, so it's fairly straightforward. However, because I do it slightly differently, I like to set up the gyro after I've set up the servos as two separate steps. We've just gone through the gyro setup, but we need to still tell it, hey, what channel we're going to use for our gyro gain. And that's pretty easy to do. So there's a couple of different ways we can do this. One is we can do it through the core screen or the atom, if you've got an atom. So normally you would go into, if I scroll down, oops, sorry, no, we don't go in there. If we just hold on to one of the widgets, we go into the Mercury menu. So now we're looking at the Mercury's inbuilt menu. We then scroll across, and here's where we can set up our different gyro parameters. There are a few spelling errors, so Richard's aware of these. So stick prioritat, that should be stick priority. So that needs to be corrected, and lec fill should be lock fill. So they'll probably get fixed up on the next firmware release. Now, if we move along, you notice this screen here, we can teach the mounting or activate the mounting learning sequence and also the stick endpoint learning sequence from this screen. So you don't have to do it from the actual Mercury itself. And this is our input mapping. So the setup assistant, when we first set up the channels, assigned these channels from the radio to the various functions. So that's all, we've confirmed that because we looked at the servos. Let's have a look the next one. So here is the gain mapping screen. So this is where we can set different channels to operate the gains for various gyro outputs. So you can have aileron A, B, C. So you've got the 3 gyro outputs can have 3 individual gyro gains, for instance. However, it's probably easier if we, for this particular example, since we're only setting the one gain, we'll just do it through the on-screen display, just so I can show you. So if I just hold down the button on my power switch, we don't do it through the iGyro menu. You go to the Setup Assistant. So Setup Assistant. And remember, the Setup Assistant remembers all our settings. So if we enter it at any point in time after we've set up the aircraft, it'll still remember everything. So we'll just scroll down to Next. And you'll notice those parameters are the same. Next. Now you can't just go, yes you can, I lied, I thought you couldn't just go to the next screen, but it looks like we can. So they're correct, rudder's correct, and here we go. It's asking us for the gain control or gain channel. So if I move my little rotary knob, so if I go back to my servo screen, you'll notice channel 10, which is the gyro gain. If I move the knob backwards and forwards a few times, it detects that that channel's moving. So it's now going to assign channel 10. It's going to map channel 10 to all the gyro functions that we're using. Now, you can actually back out of that now, so you don't have to go through, and because the next step is to set the gyro's position, etc., etc. However, if we select back now, so just go back out of these menus. Oops, I was on back, wasn't I? And then hit the escape, or back I should say, back to the normal menu. We can even exit, you don't have to exit, but we can exit. So let's have a look now. If we go back into the Mercury menu, let's see if it's populated those gyro gain with channel 10 for the relevant functions. So let's roll across. And lo and behold, remember there was all dashes here before, but now, because the system knows, the setup assistant knows that we're using aileron A and B, we've got the two functions for the aileron. So it's mapped channel 10, and we can change that, but for this example we'll just use the one gain for all of them. And same with the elevator. Remember we're using the left and right elevator, so we've got two channels operating the elevator. So it's got, oops, I went a bit too far, it's got A and B, and then only the one for the rudder. Yeah, that was good of me, wasn't it? Scrolled past. And then if I go for the rudder, we've only got the one function for the rudder, so it's assigned channel 10 to the rudder. So the gain knob now for the gyro gain, so if I vary this gain knob now, it's going to vary the gain for all those functions. So the aileron, elevator and rudder are all going to have the same gain basically. And of course you can set individual gains, even though you're using one channel to control them. You can go in and set individual gains through the gyro function within the Mercury menu, and I'll show you that in another video when we delve a bit deeper into actually setting up the gyro as far as gains and that are concerned. But now that we've got a gyro gain on there, let's now move up. So the gyro should be fully programmed now. We'll move out of this view and we'll go back to viewing the aircraft with the servos. Okay, so now we can see the servos, we can see a bit of the core screen. Not sure how well you can read it. Might be alright if you're watching on the TV. The main thing is we're going to look at the servos and the aircraft. At the moment we've got zero gain on the gyro, so you notice the gyro doesn't do anything, it's totally disabled. However, we do have stick movement. So for instance, rudder, that's my rudder stick, and the rudder servo, if I move the rudder stick to the right, so rudder, right rudder, the rudder servo moves to the right, left, left. For the elevator, I've got both servos moving up for up elevator, and then for down elevator, they both move down. And then for aileron input, I've got the right hand side servo will move up if I move my stick to the right. So basically mimicking a up elevator flight service movement. And the left aileron servo moves down, and vice versa when I move the stick to the left. Fairly straightforward. Okay, now let's see what happens when we put some gain in. So I'm just going to rotate the knob. For this example, it doesn't really matter. Got about, what, 39, say 40% gain. Let's see what happens. Now, you'll notice it's a bit hard to work out which way the servos are moving for this example. So what I recommend you do is to activate attitude assist for the rudder, for the elevator and ailerons, just temporarily, so you can determine which way the servos are responding and whether they're responding correctly. Because when attitude assist is not on, or basically heading hold, it's a bit difficult to work out what the servo's doing. So all you need to do is you can do it from your transmitter. I keep swiping down for some reason when I should be touching on the widgets. So let's go into the Mercury menu. Actually, I might just zoom into the screen so you can see this a bit clearer. Might be easier for everybody to watching. Okay, now they can see the screen a lot better. Let's go back into the Mercury's menu. And here we go. So let's have a look. This is the screen we're interested in, the fine-tuning screen. So you'll notice here we've got the aileron right, or aileron-R selected. And from that we can, or from this particular item, we can scroll to aileron left. You've got C, which is a third gyro control for aileron. Then we've got elevator right, left, etc, etc. Now, we've got a range A and a range B option. Now this is where the gyro gain setting becomes important. So basically, consider range A and range B two different memory settings, if you like, or two different options. A bit like two flight modes for your gyro, I suppose. And how do we select between range A and range B when we're flying? Well, remember back when we set up the gyro gain, so you got the gyro gain down here. we can select either positive gain or negative gain. All right, so we can have, say, negative 30%, or we can select, say, positive 30%. What's the difference? Well, the gain, when it's set to negative 30 or positive 30, is exactly the same, providing we haven't changed it in the menus. However, the negative and positive, the negative and positive, but wrong widget. The negative and positive, let me try third time lucky, basically selects from range A or range B. So when we set the gain on the knob to a positive gain setting, the range A option is selected. So under range A, we can set different gain. We can turn attitude assist on and off. We can have different flight characteristics, tip priority, lock fill, and airspeed factors. So range B, we set a negative gain. So if we want range B, so if I select range B here, we can have different parameters. So you notice the default for this gyro, or the default settings for the PowerBox systems, whenever you buy an iGyro set and you set it up on a Mercury, Pioneer, or whatever, the range B has attitude on for ailerons only. So you'll notice if we go to range A, you'll notice that'll switch to off. So that's just the default setting. If we go to the elevator inputs, or elevator function I should say, and you'll notice range A, attitude assist is off. If we go to range B, attitude assist is still off. And again, that's the default option, and it's the same for rudder. Rudder follows elevator. So the default option for PowerBox iGyro set, when you first set it up, is only range B on the ailerons has the attitude assist enabled, which is, similar to heading hold, similar but a little bit different. Okay, so ailerons have got attitude assist set on range B. Let's just do the same temporarily for our elevator. So got range B, let's set it to on. So we do it for both elevator functions. So we've got a left and right function. So they're now both on. If I go back to elevator right, that's on. Elevator left is on. We don't have to worry about elevator C because we're not using that gyro output to control anything. And the only other one that's left is the rudder. So we turn the rudder on as well. And normally you wouldn't fly with heading hold on the rudder, although we do on helicopters, but this is not a heli. So it's really only handy in this situation where we want to work out what's happening with the servos and to see what direction the servos are moving when we rotate or move the aircraft up and down, left, right, etc., etc. So now, if we move the gyro gain to a negative number, we'll have a negative gyro gain value with attitude assist on. If we select a positive number, we'll have positive gyro gain, or normal gyro gain again, say 30%. However, that's without attitude assist on any of the function inputs. Okay, let's zoom back out and let's have a look at our servos with respect to the aircraft. Okay, now I've set the gyro gain to 0. Not sure if you can see that on the screen there. So again, moving the aircraft around, no servo movement. However, we still have control with our radio, of course. Not a problem. Let's put in a gain of positive. So remember, positive gain, because we're using range B for attitude assist, range A is now selected on the gyro. However, range A doesn't have attitude assist enabled, so it's sort of a bit awkward trying to figure out what the servos are doing. Back through to 0. Now we're going to select, say, I don't know, negative 30% gain. This time, however, we're using negative 30. So now range B is enabled. And remember, range B, we've went through and enabled the heading hold or the attitude assist mode on. So let's see what happens now. Now I might just start with the rudder first because that might be the easiest. So remember rudder, if we want right rudder, we move, if we move the stick to the right, the servo moves to the right, indicating right rudder movement. And left is left on the servo as well. So left stick, left rudder. So, remember the gyro counteracts our movement. So if I pick up the aircraft, try and pick it up slowly without moving it too much. If the aircraft rotates to the left, it's going to try and put in a right rudder. The gyro is going to try and correct. So remember, right rudder is servo moving to the right. So let's move the aircraft to the left and let's see if the rudder servo now moves to the right to try and put in a right rudder command if the aircraft gets pushed to the left from wind or whatever. And look at that, servo's moving to the right, indicating it's putting a right rudder input. So I'll move it back to where it was. And remember, we're in heading hold mode, so it's going to try and hold that heading, and it's going to hold that position until the aircraft actually rotates back. So that's pretty standard setup. I'm used to gyros because I've been flying helicopters for many years. So it's just something to remember, that the gyro is putting in the opposite input to try and correct the aircraft. So remember, aircraft rotates, say, to the left, just to a wind gust or whatever. The rudder moves to the right because it's going to try and correct the aircraft back straight. So it's going to put a right rudder input until the aircraft faces roughly forwards again and you keep flying. Okay, let's try the elevator servo. So up elevator, remember, servos move up for up elevator and down for down elevator. So if I push the stick forwards, the servos move down. Now, got the aircraft here. So imagine an aircraft goes into a nosedive from wind, a gust of wind or whatever. So it's going to try and put in up elevator. So remember, up elevator is servos moving up. So if I move the nose down, the servo should move up. Let's see what happens. And there you go. The servos are moving up, indicating up elevator. So it's going to put in an up elevator command and the aircraft will come back. Obviously it happens a lot faster than that, so you don't really see much movement in the aircraft when it's actually happening. And the opposite is true. If I pitch the nose up, the system's going to give down elevator, so the servos will move down. So let's pitch the nose up, and lo and behold, the servos move down. Simple as that. Now, if I move the aircraft a bit out of the way, let's have a look at our aileron servos. Make sure the ailerons are working in the right direction. So if I move my stick to the right hand side servo indicating up aileron. So basically the aileron's going to try and move down. In other words, bank to the right. And opposite if I move my stick to the left. So right aileron, right servo moves up, left moves down, and the opposite when I go left aileron. So we've got the aircraft here. If I roll the aircraft, say to the right, the system or the gyro is going to try and put in a left aileron command. So left aileron, the servos are going to move in that direction. Left aileron goes up, right aileron goes down. Let's see what happens. So I'm going to roll the aircraft to the right, and the gyro is going to put in the opposite movement, which is left aileron. So let's bank it to the right, or roll it to the right. And look at that. Left aileron goes up, and right aileron goes down. And of course the opposite is going to happen when I rotate it in the opposite direction. Simple as that. So just doing those simple steps confirms that the gyro, or the gyro sense, is correct for all our flight surfaces. And that pretty much sets up the iGyro sat. So when you do it in practice, by yourself without having to videotape it and whatever, it's a really quick thing to do. Very simple. And like I said, the only thing you can get caught out with is when you're actually moving the aircraft to set up the gyro sensor. Sometimes if you're a little bit lazy and you happen to bump the aircraft, say you're setting the tail up, moving the tail up and down to do the tail bit, and you happen to rotate it a little bit, it can confuse the system and it thinks the rotation might be part of the up and down movement, and then you might find when you go through all this, the servos don't move in the right sequence. So just go back into the iGyro sat menu and just redo it, relearn it, and you should be good to go. Well, hopefully you found this video very informative. I know a lot of people get confused with gyros and have a hard time setting them up. but they're fairly straightforward. The next video, we're going to look at how to connect more servos to our flight surface. So at the moment, we've got, pretty much just one aileron, or one servo per aileron. We do have 2 servos for the elevator, but we've got 2 physical. In this example, I was using like a split elevator, so we've got 2 separate controls, if you like. However, the next video, I'll show you how to set up a 3 servo setup on, say, one aileron, or you can have 4, or you can have 5 servos if you wanted to. I'll show you how to do that on the Mercury. So remember the Mercury, and as far as I know, the competition off the top of my head has 3 gyro outputs per function, but that doesn't mean you're stuck with just 3 servos maximum for that function. You can match an extra servo to go in it, so you can have 4, 5, you can even have 6 if you wanted to, you can go stupid, but obviously we're not going to go that crazy. But yeah, so maybe I'll show you a 4 servo setup, 4 servos per aileron on a Mercury, etc, etc. Anyway, easy to do, so stay tuned, look out for the next video. I've been a bit slack with the videos in the last week or so because of Christmas and New Year's, but I should get back into the swing of things, making at least 1 video a week. Once we've finished off with the Mercury, probably need quite a few more videos to cover off everything in the Mercury, because I want to cover off the sequencer, servo matching, etc, etc. And once we finish that, we'll get back into the core and look at core and atom programming again. Okay, thanks all for watching, and I'll catch you on the next video.